There are talks at different levels of subtlety and sophistication. So you can be challenged and still learn things even if you're quite experienced, but it's also accessible to people that are fairly new to the language.
Okay, I think we are at time. So thanks everybody for coming to my talk today. And I'll be taking you through the riveting journey that I went through to upgrade our standards version from C++14 to 20. My name is Keith Stockdale, and a little bit about me at the start. So I'm a senior software engineer at Rare, and I first started at Rare as an intern in 2015, and then went back to university in Ireland, and then completed my degree and came back, and I've been working since 2017 at Rare. And during that time at Rare, I've been working on the rendering and engine teams, working on things like GPU particle simulations and more recently, GPU deformation systems. And if you want to learn more about me, I've got a little website here, which is all my links in it, and then links to my other talks and open source contributions and stuff like that. So on the left here, you can see there's a picture of me at our 40th birthday party. So Rare is 40 this year, which is pretty old for a game studio, and we've been celebrating over summer. And apart from being 40, what is Rare? So Rare is Microsoft, well, an Xbox first-party game studio, and we've been an Xbox game studio since about 2002, so over 20 years at this point. And in the time that we've been making games, we've released over 100 titles. Some of those you might have heard of, some you might not have heard of. For games that I've played, that would include Donkey Kong Country, GoldenEye, Banjo-Kazooie, and Viva Pinata. Now, of course, I was not working at Rare during the development of these games. I was very much a kid playing them. But what I did walk into whenever I started working at Rare was Sea of Thieves, and that's the subject of the talk today. So it's all about upgrading Sea of Thieves from C++14 to 20. Now, alongside the development of Sea of Thieves, up until very recently, we also had Everwild. So in between me giving this talk at ACU a couple of months ago and now, unfortunately, Everwild got cancelled, but it's still got a relevant part in this story. I'll be referring to it throughout the talk. So just if I reference it, that's what it was. It was a game that we were developing alongside Sea of Thieves. Okay, so the agenda for today is I'm going to talk about what Sea of Thieves is, and then give a backstory of the development of that project, and then summarize the motivations from that backstory. And then chat a little bit about the planning that went into it, and then the fun part, so all of the nice sharp edges in C++ that I came across while doing this upgrade. And then once all that's done, we can have a little chat about the conclusions, and a little bit of a talk on the future work that I might go on from this. So first off, what is Sea of Thieves? Well, it's a game, but more specifically, it's a pirate game. So it's the quintessential pirate game, I'll say. And the whole idea is you go out into the world with your friends, get into a crew, and go out into the world and do pirate things. And pirate things could be anything as stereotypical as going to dig for buried treasure, or stealing buried treasure from other pirates because you're a really good pirate. But it could also be something more fantastical, like going out into the world, into the sea, and fighting massive flaming megalodons. And for anybody that enjoys more of a story, you could just team up with Captain Jack Sparrow to defeat Davy Jones. So a huge wealth of activities you can undertake in Sea of Thieves. And I can't hope to cover it today. So if you're more interested, we've got a whole YouTube playlist called Sea of Thieves Explained. And the first video on that playlist is What is Sea of Thieves? And if you click on that, John will describe in much better detail than I, and also with a much better voice. Okay, so the beginning of the project then. So Sea of Thieves started as a project back in 2014. And at that time, we were working in Visual Studio 2013 with C++14, as you might have guessed. And right from the very start of the development, we knew we weren't just going to release this game and then do very little after that. We knew that we would always be continually developing more and more content for the game as time progressed. So right from the very start, we invested heavily into things like continuous delivery and automated testing. And if you've ever seen any of our engineering focus talks, chances are it has an automated testing bend to it, and this talk is no different. One other thing is that we are an Unreal Engine game, and we started off with Unreal Engine 4.6, and we kept taking new versions until 4.10. Now, 4.10 released in 2015. Which is nearly 10 years ago. It was November 2015. So yeah, nearly 10 years ago. So you might be asking, why stop taking new releases? And what it really comes down to is our huge number of engine mods. To date, we have over 37,500 of them. And that is to facilitate things like our water system. So if you're going to make a pirate game, you best make the sea look really good. And then other systems like our GPU particle system, but it's all throughout. And the reason for us needing to do this is because back in the old days, back 10 years ago, Unreal Engine wasn't very extensible. If you wanted to do stuff, anything rendering based, you're sort of having to modify the engine. That's not the case anymore. Unreal Engine 5 is very extensible with things like subsystems and scene view extensions. So, but yeah, we didn't have all the nice things back then. So engine mods it was. Now the problem with this is each release took more and more time to integrate because we were going off in one direction with our engine mods and Epic was going off in another. So it just took more and more time to reconcile those changes. So in the end, after 4.10, we just forked hard. So we went off in our own direction, made our game. Epic went off and continued to make on Unreal Engine. But we would cherry pick features when it made sense. So if we came across a bug and we saw that Epic had fixed it, we would just cherry pick that and that'd be fine. So development continued for us and we released in March of 2018. This is me at the game store. So it was my first game release. So of course I went out and took a picture of myself with the game on the shelves. Very exciting day for me. And we continued to release, of course, because we weren't just releasing once and then leaving it there. So we continued to release new stuff like fishing, harpoon launchers, and then we kept adding to the story of Sea of Thieves as well. So we added tall tales, like this is a screenshot from our tall tale called The Wild Rose. And then we had more tie-ins with other franchises, like with Disney and the Pirates of the Caribbean. Now, while all that's going on, Epic were also doing their thing with Unreal Engine, of course, and they released UE5 in April of 2022. And it came with big features like nanites and lumen. So these are the big features that make your game look awesome and do wizardry on the GPU. But it also came with C++17. So they upgraded from 14 to 17. Now notice they took about 5 years to do it, but they proved you could do it. So we were a bit intrigued. So we also wanted to do it. So we made a task for it and hoped that we'd get to it at some point. But about a year and a half passed, and we didn't really. And UE 5.3 released in September of 2023, and it came with an upgrade to 20. So it only took them a year and a half to get there. So again, we're thinking, if they can do it, so can we. But you might be asking, why? Why do we care about upgrading our standards version in the first place? And whatever way you slice it, it really just comes down to improved developer experience. So we wanted all the nice new things like structured bindings, like CTAD, like concepts, like designated initializers. And since I gave my talk at ACU, designated initializers is definitely the most well-used C++20 feature for us. And then we also had Everwild going off we had Everwild going in parallel as well. So it was on latest and greatest Unreal Engine. So everybody working over there had a lovely time with a very nice extensible engine with C++20. But sometimes they'd have to come back to Sea of Thieves and they'd have to go back to 14, which was never a nice experience. You had all these nice things in 20 and then you had to go back to an older dialect. It wasn't a nice experience. And then of course, the language is getting better. Straight up. So just upgrading your version, you'll find more bugs, as I'll explain throughout this talk. And you get improved warnings and also better optimizations as well. So yeah, whatever way you cut it, improved developer experience. But there's a problem. And I'm going to talk about this problem with my little line of priorities. We've all got priorities. So P0s, these are our showstoppers. These are the things where you drop everything and then go and fix it until you actually do get it fixed. So server crashes, investigating exploits, the stuff that players really hate. And then you've got your P1s. These are the things you go into the studio every day expecting to work on. So this might be a new game mechanic for the next release. It could be fixing something visual that can wait until the next release. It doesn't have to be fixed now. And then we've got P2s. So these are the types of things that are like always beetling on in the background, always being improved. So improving editor load times, improving client performance, the stuff we're always working towards in the background. And then right at the end, I've got a little section I like to call Never Gonna Happen. And that's firmly where C++20 lay. And the reason for this is it's just really hard to prioritize. C++14 is fine. We started development with it, we shipped with it, and we continue to ship with it. It does the job. and it doesn't directly improve player experience. So I've already explained it improves developer experience, that much we're sure of. But it's very hard to quantify how much that goes to our players. So it's hard to know there. And then you've got showstoppers, like libraries that don't support 1720. Now back in ACU, I mistakenly called out WinRT. I didn't mean WinRT. I meant CPlusPlusCX. So ref new, if you've ever used any of that stuff, hats, managed pointers, that stuff. And then it's also hard to gauge the amount of work required. So just to drive this home, I just thought I'd talk about the size of our code base. So Sea of Thieves is a project, so not the engine, just the game code itself, is about 28,000 odd files, which amounts to about 3 million lines of code. So that's code that we have written as humans over the last 10 years. That's not including any of the Unreal Engine generated stuff. This is just human written code. And then for the engine, about 19,500 files with about 3.5 million lines of code. Now, most of that's written by Epic, but of course, we've got a huge amount of engine mods, so we've got a decent contribution to that 3.5 million. And then off to the side, we have Engine Test Project. Now, it does what it says in the tin. It's a project that we use to test our engine mods. And it's a bit smaller, so about 580 files with about 56,000 lines of code. So what this all means is, it's very hard to know how much of this code we'd have to change in the upgrade. So would it be 100 files? Would it be 1,000 files? Who knows? We didn't really know. So yeah, very hard to prioritize because of all this. But then two things happened. The first of these two things is we've released Season 11, which was our release in early of 2024. And it came with lovely new features for our players to play with. But smuggled in there was also our upgrade to the new GDK. So before, we were on the old XDK, so that's Xbox Development Kit, and that's where all of our really old libraries lay. That's where all the dependencies were. So once we chucked all that out, and we got this nice new shiny game development kit, we unlocked our potential to actually go to newer versions, which was great. But it didn't give us the push. We were able to do it now, but we didn't have the push. That's where number 2 came, where we released on PS5. So that came in April of 2024. Now, I mentioned before that we are a first-party Xbox game studio. So for 20 years, MSVC is all we've ever needed. PlayStation 5 does not compile with MSVC, funny enough. It's got its own compiler. So the first thing we need to do is to port it and get it to compile. But of course, we have been with MSVC all the time, so issues started to appear very quickly, such as compiler-specific macros. Now, most people here would think, okay, if you come across that there, just use something more standard, like memsets, perhaps. But we went a different direction. We went with a bit of preprocessor branching. That's what the next slide's for. Why, indeed? So why would we not just fix the code? Well, just to explain this, let's go through the pros and cons. Pros, minimal tech debt, obviously. You just fix it there and there. But the thing is, we are a live game. So we don't want to be breaking things while we're doing this here in the background. So the problem here is we could be breaking other platforms, and that's a real risk. And to mitigate that risk, you'd have to do a lot more validation verification. You'd have to move slower. So instead, the pros for preprocessor branching is much less risk, because you're only technically changing the code for the PS5 version, not anything else. And this just basically means the whole process is faster. But of course, there's the cons. You're always accruing tech debt here. And most people would look at the word debt and just think that's inherently bad, but debt's a tool. Use it to get there at some point. I will take questions at the end, sorry. Yes, so every time we were doing one of these changes, we would tag it up in our, for tasks to come back later, and we have been doing it. So we've been patching it up over the last year, and most of the tech debt is gone at this point. Now, compiler-specific macros is one thing, but then other sorts of issues start to arise. So this code would compile just fine with Sea of Thieves before all of this here, but the PS5 compiler would not. And the reason for that is if you just look at the top, function template, that actually requires type name to be there. And the reason for that is because ret type is a dependent name. So everything after the scope operator there, that's a dependent name. So you have to tell the compiler that's a type name. It is not like a static variable or anything out there. Why? Why is this only showing up now? Why is it taking the PS5 compiler to tell us that we are not writing correct C++? It all comes down to permissive mode in MSVC. And this is the default for 14 and 17. And we started in 14, so of course that's what we got. And we never really thought about it after that, to be quite honest, until all this happened. And what permissive mode basically means is it's non-standard conformance C++. You could maybe call it Microsoft C++ if you want it. Now, in the last 10 years, the Microsoft compiler team have been making large strides towards standards conformance. So like, I think it was back in 2017, they came out with permissive minus. So that's a way of taking away the permissiveness, I guess. And then as they're moving more towards standards conformance, permissive minus is the default for 20. So as soon as you switch 20 on, you get standards conformance mode, which is great. And if you want to read more about this here and reasoning and stuff, there's a great blog post about it at this link. Now, this is all good, and we found all this out from the port, and we released the port and everything. But there were two examples that kicked me into gear to like go and pay back this tech debt, to go and actually do something about this terribleness. The first is nested lambdas. So if you've got a struct here and you've got a member function for it, and inside that member function we have a couple of nested, immediately invoked Lambda expressions. And then we're just capturing this and just bringing this down. And then inside the innermost one, we return the size of whatever this is. Now, and then we call that function and print it out. Now, in every standards conformant compiler, this will return 1 because A it's got a bool in it, so it's only 1 byte in size, so it'll return 1. But for us in permissive land, this would return 8. And the reason for that is because the this in the inner immediately invoked lambda there, that's not actually referring to the captured this in the outer. It's actually referring to the lambda object itself. So because the outer lambda has captured a pointer, and in our architecture, pointers are 8 bytes in size, we get 8. Now this is scary because we've got code that compiles in both modes here, but we're getting very different results, which is obviously a really bad way to be. So that's example number 1. Example number 2 is copulation. So say you have a struct, a class like this, and every time you invoke a special member function, it increments a global. And then in some function, we just create a lambda, and this lambda, all it does is create an object of one of these structs, returns it, and then we just call our lambda and assign it to a variable, then print out the global. In every standards compliant compiler, you will get 1 here, because you get copulation. You never actually do that whole construction inside the lambda and then the move out of the lambda and then the destruction at the end of the lambda. None of that, all that's elided away. That doesn't happen. You just get the construction, which is great. But with permissive C++, whether you get copulation or not depends on compiler flags, such as optimization flags, because it would treat copulation as an optimization. Now, you might be thinking, it is kind of an optimization, but it's an optimization with very, very different behavior. So in debug builds, this would actually return 3 for us, because you would get the construction, the move, and then the destruction at the end, which isn't good. So all this basically means permissive minus is important to us. Permissive C++ is detrimental to our developer experience. Just all up. Compilers should probably interpret the code in the same way. That's probably a bare minimum. And more copulation is great, because sometimes we do need debug builds. Especially whenever you're using stuff like dynamic deops now, if anybody's using it. It's not really great whenever you hit a breakpoint and then you start getting very different behavior. That's where you start seeing Heisenbugs. Now, all of this basically means is that we can go back to our line of priorities and firmly put this as a P2. This is something we absolutely definitely want. It's probably something our players don't care about. So it goes into P2 and works in the background. And all of this allowed me to reprioritize C++20 and sneak it in. And the reason I could justify this to myself was permissive minus should help us towards 20, because it's the default for 20. As soon as you turn on 20, you get permissive minus by default. Now you can turn permissiveness back on, and people might be thinking, well, why not just do that there? But I'm in the business now of paying back tech debt of over 10 years. So let's not do that. Let's just actually do the right thing from the get-go. And the work to do both of these things is largely the same. So you flick a switch in the compiler, then you hit compile, you fix some stuff, rinse and repeat until there's nothing more to fix. Okay, so plan of action then. We all need a plan before you start diving into things, otherwise you might go down rabbit holes. So first and foremost, this is background work. I was doing this in my Friday learning time, so every Friday afternoon before I go off for the weekend, I would be upgrading Sea of Thieves. And this is basically because Sea of Thieves is a game, again. I want to just stress that. So our first and foremost priority is to our players, and players love to see new features. They like the game performing better. They like seeing bug fixes, all of that there. They don't particularly care what version of C++ we're on. We're not going to put that onto our release notes, as you might expect. But the nice thing about all this is, the flip side is, there's no real deadline. I can just do this in the background, and whenever it lands, and it will always be getting better as we do it, which is good. Now, I had two rules whenever I started off this. First off was no fixing things, which is basically a rewording of Hiram's law. So I do not want to change behavior in any of this. My sole focus is just getting to 20 without breaking anything. If I come across anything that might look like I might change behavior, I'm not doing it. I'm finding another way. And the reason for this is because the video I have here is something that is cemented into my head. This is the last time I tried to fix something. I tried to fix some particle behavior. So in this video here, you're supposed to see rocks being ejected from this volcano with massive, big, flaming smoke plumes coming out behind the rocks. But all we're getting is very small, little, weak fireballs out of the end, almost as if it's like a Bowser attack in the old Super Mario games. So, of course, whenever I fixed this particle behavior, it broke everything that depended on that broken behavior. So we don't want that. We've learned our lesson. We're not doing that again. Now, the second rule is small changes. I am not going to do this in one big, massive mega commit. So I'm going to divide everything into nice, small change lists, and there's two reasons for this. Number one, easier to review. No engineer wants to see 300, 400 line changes come across and then be expected to review that. It's extremely hard to do that, and it's very hard to know the ramifications for that. It's much easier to review something that's maybe like 15, 20 lines of code. There's more of a chance that you're going to get a good, honest review out of that than something that's hundreds of lines long. The other reason is it's easier to undo if something breaks. So say I broke rule number one, and I did in fact break something, there's more of a chance of somebody coming in and building on top of my broken code if it's one big massive change as compared to small changes. And all this here allows us to basically make the compiler switch the last change at the end. So it should just be a one-line change right at the end. So you do all the fixes first, and then you submit the compiler switch. So there's three parts to this work. First, you might guess, is standards conformance. That is going to be our biggest bang for buck. So it's all about getting these two compilers to see the same code, shake hands, and say they do the same thing. And then step two, we get some nice things with C++17. So we get some structured bindings, some CTAD, if const expr, some guaranteed copulation again, which is very nice. And then final step, C++20, obviously. And there we get the big stuff like concepts, designated initializers, and spaceships. Everybody loves a good spaceship. So let the fun begin. Now, the fun begins with permissive minus with a thing called two-phase name lookup. And if you've never come across two-phase name lookup, it's effectively the rules that govern name resolution in templates. And surprise, surprise, permissive C++ doesn't follow these rules. So two-phase name lookup. There's two phases for name lookup. You've got phase one, which is definition time of the template, and then you've got instantiation time of the template. So any name that does not depend on the template arguments within a template can be resolved at definition time, because it's always going to be the same regardless of the template instantiation. So it's done then. And then for any name that does need resolved at instantiation time, so it depends on the template argument, yeah, that's done at instantiation. Now, with permissive C++, we get what I'm going to call single-phase name lookup, where everything is resolved at instantiation time. The consequence of that is the code on the right here will compile just fine with permissive C++, because doThing is never actually instantiated. We never call it. So it never evaluates anything inside the curly braces. So anything inside the function body doesn't look at, doesn't care about. It's effectively a macro. And I make a very explicit that it's in between the curly braces, the function body only. There is some resolution that does happen in the signature, but anything in between the curly braces, that's a macro essentially. And there's a really good blog from the compiler team about this and like all the history behind it, why they went this way, and then all their work towards more standards conformance. So if you want to learn more there, go for it. Now, the first place you'll find this here is with accessing templated base class members. So say you have a template base, and then you have a derived template, which has a member function, and we try to call a base class member there. The problem here is the call to do the thing there doesn't depend on T. There's nothing in that line that mentions T. The compiler will try to resolve that at definition time. The problem here is base T does not exist at definition time because base T depends on T. So it only gets done at instantiation time. So what this will do instead is one of two things. Well, it'll go out to, one of two things. It'll go out to the global namespace and try and look for a function called doTheThing, and it won't find it, in which case you'll get a compilation error. That's the best case scenario. The other thing that might happen is it actually does find a global function with that same name. It'll compile, and you might find the bug very soon, or not at all. Who knows? So yeah, that's quite scary. So the way that you have to fix this is you have to delay the resolution of that call to do the thing until instantiation time. And the way that most people will do that is dereferencing this. So this is like basically the only reason that you'd ever dereference this pointer in C++, as far as I'm aware, is to do this. So if you've ever wondered why you've had to do it, that's why. It's because of two-phase name lookup. Goes sort of the same for templates as well. So say we have a struct template, and inside of it we've got a static member function which is also a template, and we try to call that static member function from outside the context of all of that. This would compile just fine for us in permissive C++. Completely legit, be fine. But as soon as you bring conformance into it, you'll start to get really weird error messages. So this is just for MSVC. So it's starting to talk about things like it's expecting an expression. I definitely wrote an expression. Expected a semicolon, definitely had a semicolon. And it didn't expect closing the template argument list. Well, why would you think that? If I'm going to open it, I want to close it, right? And what this all comes down to is the fact that doTheThing is a dependent name. So what this has actually got to do is it's got to try and resolve doTheThing as if it's essentially a static member. So it's doing here, doTheThing is less than T, which obviously makes absolutely no sense, and hence the nonsensical error messages. So you have to tell the compiler here, essentially, that's a template. So if you ever come across this type of syntax, that's why. It's because you have to actually tell the compiler this dependent name is in fact a template. It also works for non-static member functions as well, so like you get .template as well. Okay, so static assert false. So this was a problem for us. Tenses matter here. So it's very common that we make a template and we only want it to be instantiated or specialized for certain arguments. So in this case, we've got only int. We only want it to be valid for ints. And the way we would want to enforce this is to have like a static assert here. So if you ever instantiate this primary template, you'll just get an immediate compilation error and you print out a nice compilation message to tell people what they did wrong. But again, there's nothing in that line, nothing in that static assert that depends on T. So this will be resolved at definition time. Only int is always defined. So what you actually get here is an ill-formed program, no diagnostic required, or at least you did. And the way you'd fix this is making that expression, the condition, be evaluated at instantiation time. So people would make variable templates, maybe called T is always false, that always evaluates false whatever template you give it. I'm saying was here, or at least I'm trying to, because Barry Revson came in with P2593, which then got rolled into CWG 2518. And basically he thought this is probably something that should be an exception to this rule. So it's ill-formed here, but he says it probably should be well-formed. And this was a bug that was fixed and retroactively applied to every version from 11 onwards. And this came out with GCC 13 and 17. So those compilers released in 2023, I believe. And then about a year later, MSVC came along with 19.40. Unfortunately, I was doing all of this work in 3.8. So I just missed it. So we had to go around and have T is always false everywhere. Okay, so implicit conversions then. So there's some very interesting and odd implicit conversions that permissive C++ gave us. The first of which is implicit conversions from false to null pointer, which led to interesting stuff. Every one of these I fixed, it seemed to be benign. So yeah, odd. Now in C++ 11, we got scoped enumerations, right? The whole point of these, well, one of the points is more type safety for enums. You shouldn't be able to treat an enumeration as if it's an int. You shouldn't be able to add them and stuff like that. And that was largely the case with permissive C++, except for one place. You could actually specify the size of an array with an enumeration. Now, in most other cases, you would have to do the static cast, which is nice. But there was also an implicit conversion from int to the actual enumerations. You could do something like this. Easy enough to fix, but still quite weird. Okay, so direct versus copy initialization. There are very subtle differences in how these are done in the language. So say we've got an A, and we've got a B, which you can construct from an A, and you can construct a C from a B. Obviously, these things should be explicit, but just for the purposes of this slide. In permissive C++, from what I could see, direct and copy initialization are effectively the same thing. But in standard C++, that's not the case. You have to use direct initialization here to get the conversion chain to work. Now, you might be thinking, where would I ever see this? Well, if you look in your code base and you've got any class that has a non-explicit constructor that takes a std string, you've got this because you can construct that object from a string literal, which can be constructed, which gets a default conversion to std string, which then goes to your class. So it pops up. Now, after all of this, we're compiling. So if you've never seen Unreal Engine, this is what it looks like. Well, at least this is what Unreal Engine 4 looks like. If you've ever used 5, it looks much prettier, but same sort of thing. Now, we're not done because we've got tests, of course. So we run this against our battery of tests, and surprise, surprise, we start seeing things fail. So we have to go back and figure out what's going on, and surprise, surprise, it's our good friend, name lookup again. So this is a watered down version of what I did come across. So we've got a function template here, takes a T and a U, and returns 0. And then we've got another function template which calls our initial one with a T and a float. And then after that definition, we have an overload of our initial function template. And the overload is for an int and a T, and it returns 1. Now, with permissive C++, this will return 1, because at the point of instantiation of us calling getValue, the entire overload set is known to us. That's not the case with standard C++. With standard C++, we get 0. So what's happening here? And it just comes to, you can actually find what's happening here on CPP reference. So this is from CPP reference. And the bullet point that's relevant here is the first one. So we're not using namespaces here, so there's no argument-dependent lookup. So non-argument-dependent lookup examines function declarations with external linkage that are visible from the template definition, so not the instantiation. You can get it to work with instantiation if you bring in ADL to the whole thing. So if we were using namespaces and leaning on ADL, it would have been fine, but that wasn't the case. Now this all sounded quite familiar to me because at the time I was watching some old CppCon talks, and Matus Push, he had a great Back to Basics talk back in 2022 about this very thing. So he's able to talk about this for 15 minutes, which is nice. I would recommend going and watching that. So after we fix that, everything's going green. And we can submit at this point. And the nice thing is this never came back. Our automated test caught everything, which is pretty sweet. And to this day, like nothing seems to have broken. And that was nearly a year at this point, a year ago. So we're pretty confident we've got everything. Okay, so now on to C++ 17. So from this point on, we're in standard land. We don't have any weird Microsoft C++ going on. This is standard land now. So the first thing we came across was std auto pointer. So if you've never come across this, maybe you're new to the language. This is effectively C++'s first smart pointer. It came out with C++ 98, and it was a unique pointer without move semantics. So if you've got this code here, it'll print out hello CppCon by CppCon, because you get the construction, and then at the end of main, you get the destruction as well. Now, of course, in C++ 11, we got move semantics. So we also got unique pointer, which completely outmoded auto pointer. It was immediately deprecated. There was no more need for it. There's no point in using it. So we were still using auto pointer in a third-party library that we were using. So we were using it for our testing framework. So we weren't using it directly, but we still had a dependency on it. So the fix here that we had to do was just upgrade that library from version 1.0.2 to version 5. So it was a large version jump. The nice thing was the maintainer of that library did a really good job. It didn't take me much time at all. It took me a couple of hours to actually get the upgrade in, so that was nice. Next thing, incrementing bools. So again, this is standard C++. It was deprecated in 98, to be fair, but it was standard until 17, and then in 17 got removed. So the obvious fix here is treat a bool like a bool. And that's it. It didn't take much to go from 14 to 17, at least compiling-wise. Now, of course, we go back to our tests and we find, yes, indeed, we are getting failures. Where's that coming from? So the little thing I'm going to call expression order fun. Now, at ACU, I made an absolute mess of this slide, so I'm going to do a bit better here, hopefully. I'm going to go a bit slower. So prior to 17, there was no defined order in which sub-expressions were evaluated in a full expression. That was all implementation defined and could be affected by things like your optimization level, even if it was a virtual overload or something like that. There was lots of things that went into it. But what it came down to for us is that middle line, where we are accessing the 0th element in our map and then assigning the size to it, for us, with optimizations on, it would do the pushback, it would do the insert first. So whenever you access a member that doesn't exist in a map, it'll do the insertion for you, right? So that insertion would happen first, then the call to size. So we would get 1 printed out here. But with C++17, the expression order is much more well-defined, and the opposite happens. So the way that you had to fix this was be very explicit about what we wanted to happen first. We wanted the insertion to happen first, so we do the insertion first. We'd access the 0th element, and then we would assign the size to the 0th element, and we'd get our old behavior back. This is probably the hardest thing that went into the upgrade. It took me a large amount of time, because it wasn't as simple as these 3 lines of code. I'll tell you that much. It was over a huge amount of our code base. So yeah. Okay, how about now? Well, after that, everything's green. And just like with permissive minus, we submit, and it never came back out again, which is great. How are we doing for time? Excellent. Okay, so now we can get on to the big one. So C++ 20. So the first bit of trivia here is aggregate initialization. So up to 20, there were some places where you could do aggregate initialization when the struct that you were trying to aggregate initialize wasn't actually an aggregate. So you could actually aggregate initialize this, even though you've defined a constructor. Yes, it's defaulted, but it's still technically defined. So that'll be fine. So the obvious fix here is just to remove that silly constructor that doesn't need to be there anymore. Problem solved. This one was fun. So this was the first instance where I was justified in the fact that C++20 would improve our code. We had a lot of this because we would have O-stream operators to print out objects of certain types that field assertions in our testing framework. And everything in Unreal, every string in Unreal Engine is a wide string because Windows and legacy. So everything's a wide string, but we were piping everything out into a narrow character O-stream. So of course, we weren't getting hello CppCon printed out here. Of course not. We were getting the memory address of it because it was taking the void pointer overload. So in C++20, a lot of these overloads were explicitly deleted. So you got this here, which is nice. So this pointed out a major failing in part of our testing framework. So that was nice. We got a good improvement there. Now the next thing is result of was deprecated in C++17 in favor of invoke result. And if you've never used these type traits before, you effectively give it a callable like this, and it will return you the return type of that callable. This is a pretty simple find and replace. You just, it's a very easy one, that one. What wasn't easy was this. So non-const comparison operators. Say we have this, perfectly fine in 17. In 20, if you're on MSVC, there's a hard error. Not allowed. In GCC and Clang, it is a warning. Probably should be an error, to be fair, once I'll go into it. So what the error is this. It's saying overloaded functions. Immediately, I'm wondering, functions? I wrote 1. So where's that coming from? They have similar conversions, and then the next 2 lines basically give me the overload set, and both of them look exactly the same to me, except in the second line it says synthesized expression y is equal to x. Don't really know what that means. Synthesized probably means the compiler's doing some shenanigans for me. So whenever I get something like this, I tend to go to another compiler to see if it gives me a better error message. So I went off to GCC. And as you can see, it's a warning. And it tells me again, these are ambiguous, alluding to the fact there's 2. And then the next 2 lines are basically the same as MSVC. But then it tells me it's reversed. So maybe that y is equal to x is like reversal, I guess. But the final line, this is the best line. This is an error that tells me how to fix my code. This is what we should all strive for. Error messages that actually tell you how to fix your code. This is what you want. So, of course, I go back and say, OK, I'll put my little const in there. And it did fix it. That was it. But I'm still scratching my head. Why? I didn't want to accept this. I wanted to actually understand why this was happening. And C++ reference actually failed me. I could not find the answer there. So I dived into the standard, and I found this little paragraph section. And it really comes with the spaceship operator. And this passage is all about relational and equality operators. So the bullet point that matters here is the second one. So for relational and equality operators, a synthesized candidate is added to the candidate set. So there's the compiler generating this function, where the order of the two parameters is reversed. Y is equal to X. So I guess that's where MSVC is getting it from. I don't know why they expected me to understand what Y is equal to X meant, but yeah, there you go. So essentially what was being generated was you had one function, the one I wrote, which was taken in the first parameter, which is the this pointer, which was non-const. And then you have a const version for the second parameter, and then that reversed. But the thing is it ambiguous is it possible to get ambiguities between a pointer and a reference? I would say no, so I'm still scratching my head at this point. That's foreshadowing for later. But after this here, it compiles. But the thing is, and then, yeah, it compiles, and then we go to our test, and surprise, surprise, everything passed. There was no behavioral changes here whatsoever, so that was nice. So we're done, right, at this point? Yes, but no. The problem with 20 is it deprecated a lot of bad stuff. And with deprecations comes warnings. So if I submitted at this point, I would be polluting all of the engineers working on Sea of Thieves with a huge amount of warnings every time they compiled, which is not great. So I decided to go off and fix the most egregious of things. So comparing arrays was the first. So say we have two arrays here, and they both contain the same thing, 1, 2, 3. And then we compare them. This will never return true, because you can't compare arrays, of course. You get pointer decay here. So you're actually comparing the addresses of these arrays, and of course, the two arrays can never be in the same memory location, so you'll always get false. So you might be expecting, okay, so to fix this, you might do like a mem compare or something like that. But of course, the problem here is this function has never returned false in 10 years of development. To fix this would be to change behavior. So we didn't do that. Instead, I just made it very explicit that I want to do this. I don't want to do this. I just know this will fix it. So then make a task and hopefully come back to it later. And I can say that I have come back to this later. I did check out what was going on here. This was from a very old part of Unreal Engine that we were never actually using. So we just threw it away. Happy days, job fix. Next, volatile equals thread safe, right? No, absolutely not. And in C++ 20, a lot of operations on volatile objects were deprecated because whenever you try to do an increment like this here, you can kind of assume that the author of this code meant for this to be an atomic operation or intended it to be, but that is not the case whatsoever. Again, you might be expecting throw an atomic in there, but again, I'm not entirely sure that would not involve changing behavior. So I'm not doing that. I just made it very clear that I'm not expecting any atomic stuff here. And of course, this is a possible bug. Possible race conditions. I'm definitely not touching race conditions with a barge pull. So we make a task, come back to it later. And in fact, we have. Two of our engine programmers have come back to our lock-free queues and fixed stuff up. So that's quite nice. I wouldn't want to touch it though. So if you want to learn more about volatile, Ben Sachs had a really good talk last year at CppCon where he talks about what volatile means and what it doesn't mean. So yeah, really good talk on that. Now, capturing this with the default capture. This is a hard one, but it's got very interesting ramifications. So say we have a struct, we've got two member functions, and inside the second member function, we call the first within a lambda. And we capture this pointer with the default value capture. Right? So this is completely fine in 17. In 20, though, this is a warning. This is deprecated, because it is deprecated behavior to try and capture this pointer with the default value capture. And the reason for that is because in 17, we got the ability to dereference this pointer in your capture list. So you could actually dereference the value of this, essentially. Rather than just getting the pointer itself, you get the object pointed to by that pointer. So what the author of the paper here took this to mean was that it was ambiguous as to whether you wanted to capture the pointer itself or the object pointed to by the pointer. Now, in the first reading of this paper, I didn't really take it I didn't understand why, didn't get the logic, because if I have an integer pointer and I try to capture it by value, I don't expect it to dereference for me. That didn't make sense to me. Then you read on in this paper, and you learn more about what the this pointer is. And the thing is that the this pointer, it came into the language before references. The this pointer is not really a pointer. The only reason we use pointer syntax is because that's what was available at the time. It's more like a reference. And if I harken back to the non-const comparison operator example, remember we're getting ambiguities between the this pointer and a reference. Well, that's not the case. You're getting ambiguities between references and const references. So that's where that's coming in. Now, this paper here, it gave you a good way of getting around this. So you could just explicitly capture the this pointer. The problem, though, is this is only valid syntax in 20. I'm doing all these fixes in 17. So this is not something I can do. So what I elected to do instead was to capture everything explicitly. And we have a lot of this code in Sea of Thieves. We're a network game. And with network games, we have a lot of futures. We've got a lot of continuations. Basically, functions, Lambda is where we want to capture everything by value so we don't get dangling references, right? So we had a lot of this. So there's lots to fix up here. The other option I could have done was like just dealt with the warning and then came back to it later. But again, I didn't want to spam everybody with warnings. Okay, but the nice thing is, after all this, we're done. It's done. That's all the work that went into it, which is great. So before we're talking about conclusions and statistics and stuff, I just want to talk about, just remind everybody the size of our code base. So about 6.5 million lines of code, thereabouts. So upgrade statistics then. So for permissive minus, so enabling that, we only touched 215 files. So out of 6.5 million, that's not bad, to be quite honest. And that involved about 369 individual diffs, with about 30 changeless and 6 test cases to fix up. Not too bad. 17 was significantly easier, so only 68 files changed with 31 individual changes. And the vast majority of those files changed was just upgrading that library. There's very little else. And then that came in with 4 changeless and 2 test to fix. Granted, they were definitely the 2 hardest tests to fix, but still only 2. 20, bit of a leg up, bit harder. 111 files changed or added with 408 diffs. Majority of that was the default capture, to be quite honest. Number of changeless, 18, and 0 test to fix. Didn't break any behavior, which is nice. So now you might be asking, so how hard was it? Initially, whenever I made this slide, I had some arbitrary scale of 1 to 10, but that was meaningless. So I'm just going to give you 2 metrics here. So the 2 metrics I'm going to give you is time to first successful compilation. So that's the time of from me flicking the switch and then getting to the editor. So no test fixing, no warning fixing, just like minimum time to actually get the thing to compile and work. And then time to actually submit the work to mainline, right? So enabling permissive minus took about 2 days. So we're talking about 4 or 5 of my Friday afternoons for that. But the thing is, it's very easy to hack something together. It is another thing to actually submit something responsibly and get it into production code. Because again, we're a live game, right? I don't want to step on people's toes and do something wrong. So this took about 4 months to actually get in, all in all. So there's a lot of things to contend with here. There's a lot of other releases that take priority, et cetera, et cetera. So I got that in within 4 months. Going to 17 was significantly faster. So that took me an afternoon. It took me barely any time at all. Most of the time was spent upgrading that library. Time to submit was also pretty quick, 2 weeks. We were only on standard C++14 for about 2 weeks. And the majority of that 2 weeks was me finding those 2 expression order failures. So pretty easy going to 17 for us. Going from 17 to 20, a bit harder, maybe 2 or 3 Friday afternoons. And it took about 3 months to do. Now at Q, I couldn't actually tell you why it took 3 months, because at the time we were gearing up to release on yet another platform. We were gearing up to release on Battle.net. And there was no way that I was going to jeopardize that release for upgrading to C++20. So I waited my turn, made sure all of that there was fine and everything was going to work, and then I got my stuff in. Okay, so we're C++ engineers. We really care about build times, and as we should. So for these stats, these are the specs that we're using. So it's no slouch, 32 cores, 128 gigs of RAM. We're also using, so the build config is development editor. So for Unreal Engine, that's the default. And the main thing to note here is that's O2, essentially. That's O2 optimizations. And with MSVC 19.42. Now you'll notice that I'm not actually going to talk about 14 here. And the reason for that is because at the time of me getting these timings, we'd been on 17 for quite a while. And there was no way of going back to 14 for these, unfortunately. And I hadn't submitted 20 yet, so it was very easy to go between 17 and 20. So in place of 14, I've got permissive 17 and standard 17. So permissive 17, so Microsoft C++ 17, that took about 13 minutes to build. So 6.5 million lines of code. There's actually more because of Unreal generated code, but yeah, not too bad. 13 minutes to compile. Now, going to standard C++ 17, we saw real gains. So 13 seconds, 13, 14 seconds. Now that's money because we've got a massive CI system. We're always building the editor. So every second counts. That's less time to build. That's less energy taken to build. Yeah, that's impact right there. And then going to 20. So as I said, I hadn't actually submitted 20 yet. So we hadn't actually used any 20 features. And we're C++, so we don't pay for what we don't use, right? So yeah, there wasn't any build time increases there really. That 47 was within noise. I kept doing more, and I kept getting sometimes 20 was faster than 17, sometimes not. So like it's, yeah, you're not really paying for anything there, which is nice. So what did we actually achieve with all this work then? So Sea of Thieves is even more cross-platform. Before this here, I guess you could argue it, but with all the pre-processor branching, you'd have to squint. So there's a lot less of that now. It's a lot more standard, which is nice, a lot more portable. And we've got faster debug builds, which is excellent. So like, what I mean by that there is like debug optimizations. We're getting compilation everywhere, which is nice. And as I said, it found a real error in our whole testing framework with the printing out of wide strings on narrow character O streams. So yeah, major upgrade to our testing framework there. And just all up better error detection. The language is getting better. It's finding more stuff at compile time, moving more runtime errors to compile time. So big wins there. And of course, we've got some awesome new features. And our devs do love them. We've started using concepts a lot. We've got a lot of concept headers now. So just to give some quotes here. So Sam was our previous engine team intern. He's went back to university to complete his degree. But in his time working at Rare, he worked mostly on Everwild. But the thing is, as I said at the start, sometimes you have to move back to Sea of Thieves for certain things. And this is one of the things he wrote in his devlogs. So he was roped back into Sea of Thieves and was very sad he couldn't use designated initializer anymore. And then once I did get 20 in, he was immediately using concepts for a bit of unit testing. So yeah, we're using them quite liberally now, especially designated initializers. They're rampant throughout Sea of Thieves at this point. Okay, takeaways then. I'm going to just stick my neck out and just say upgrading is definitely worth a try. Now, I'm speaking from the privilege of a game developer. The worst thing that I can do is get somebody mad on Reddit. I am not going to make people have worse health. I'm not going to make people lose money. So take that for what it's worth. And newer standards improve code quality. I think that's fairly evident from all of this. And selfishly, I learned a lot, both from actually doing the work and then also giving these conference talks, because you probably should know what you're talking about before getting up on the stage. And also, even if you're really super duper sure that you are only going to use one compiler, still compile with multiple ones. Yeah, so we're a first-party studio, and we still somehow managed to get onto PS5. That was definitely not in the cards at the very start of our development. We absolutely never thought it was going to happen, and yet it did. So learn from those mistakes. And then, yeah, I'll just harp on this one more time. Automated tests are exceptionally helpful. They reduced the risk for us a lot. We were a lot more confident because things were failing, and they were failing for valid reasons. So yeah, automated tests, exceptionally helpful for this type of stuff. And build times don't get worse. You only pay for what you don't use. Good. Okay, so future work. I had this with Accu as well, but I'll just give some updates. So removing more of this, these are going away quite fast, which is quite nice. These are now limited to very specific engine changes where you have to do different things with the PS5 because you have to do different things. Enabling warnings as errors, quite close to this now, which I'm very happy about. I've got like 2 changes left to go. And then re-enabling warnings that were disabled, I'll leave that for some Christmas fun probably. And then 23 and beyond. I'm getting very excited for 26 after seeing some talks today. So sooner as we can go to that, the better. Okay, and that's everything. A little bit of a Q&A if anybody wants to ask any questions.
Thanks for talk. Very enjoyable. Okay, so 1 day for development, 4 months for rollout.
Yes.
How many rollbacks? One question. Second question. So all tests are green. How many crashes in production?
So to answer your first question, never came back out. Never rolled back. So it found everything. Crashes, I never got tagged in anything, to be quite honest. So I don't think there was any, really. There was no increased crash rate. Most of our crashes come from GPU hangs. So that's where most of the things come from.
So is the game running somewhere on millions of users elsewhere?
Yeah.
How do you know that's not crashing?
We've got really good crash reporting. So
Okay.
we get a lot of, as soon as you get a crash, we get something.
With your ratio of not test coverage, but with your ratio of test code and product code, how do you reach to that level of test coverage?
So coverage is very hard to do, especially in a game engine. It's not really a meaningful...
Right, how you test like pixels, waves.
Well, no, because you can definitely test lots of gameplay logic. We do have rendering tests, and I do have a GDC talk talking about how you can actually get away from...
Because your example with the Volcano was purely graphics, right?
Yeah, it was, yes. And that's a real sore point for us. Yeah. Again, I've given a talk about that. That's getting better for us.
Yeah. Thanks again. It was very enjoyable to
listen to this. Thank you very much.
Gabriel Distress here, the person mostly responsible for your pain. This is the first time actually seeing a customer like telling the stories of porting from whatever it was before to 20. I have internal team that yell at me, but this is the first time. So I think you have a selling point, which is when your program is conforming, it compiles faster.
Yes, that was undeniable. That was undeniable for us. Yes, it was.
So the split permissive minus and language version was really necessary because otherwise we couldn't have done anything.
Yes, absolutely, yes.
And permissive minus was also necessary because at the time I was working on modules implementation.
Yeah.
And there is no way I could implement modules if I don't have to face them lookup and fix all the other stuff because as you saw, permissive is like, I don't know. So again, apologies for making it very painful for you, but I'm really happy to see the end result.
Yeah, so are we.
I just want to say I'm a big fan of Rare, so this was really cool. The question I had is, so obviously Sea of Thieves is like known for how many mods you have, and that's what you were talking about, like engine mods specifically.
Yeah.
So, I mean, it's an obvious conclusion that it would be impossible to just automatically update. I guess my question is, would you have to build the entire game from scratch to upgrade to Unreal Engine 5? Like, obviously it would be worth it in terms of like the graphics and like the water textures, but how much of like, do you think your code base would you have to rebuild like from scratch, upgrading to Unreal Engine 5?
It's such a hard question. And just to talk about one particular part, so our GPU particle system in particular, that is super custom at this point. The thought of even trying to port those assets into UE5.
Impossible.
Very scary, definitely.
Yeah.
Nothing's impossible,
Right,
but very scary, certainly. And then then that's only one particular part. That's one bit that I'm very interested myself because I'm the owner of the GPU particle system, but it goes throughout everything. Yeah.
And then how much to make Conker's bad fur day 2?
No comment.
It was worth a shot, right?
Yeah, can't blame you.
Yeah, I was just wondering. I noticed like you were using macros.
Yes.
Could you have just kind of had like one macro where you basically just created something that determined what your build platform was, and then use context for if? And second of all, I noticed you were talking about build times. How would like if you had also supported or gone with modules, at least for the standard library implementations, would that really help?
So the first question, why did we not use like macros to like do it all in place? It's because that again could have involved breaking other platforms, because like it's still, you're still fixing it for that there. So like we just didn't do that, and also it made it more visible.
Well, no, I was just saying. No, I think the idea is like you still put the macro, but you put one place where you put the macro definitions, and you have a variable or an enum that actually says that you have the that you have like what your build target is.
Yes.
And then you only have that one macro that you evaluated once, and then you still have those special cases for if you're building for PS5 or PS6 or Switch or Wii or whatever, you have those special cases for different.
So I guess the answer to that is I don't know, but now that I think about it, we just didn't have everything be in zero memory or everything be in one thing. So there'd be lots of special cases. So I guess the decision made there was just, number one, maybe visibility, and number two, just speed, I guess. Like just not even having to think about it, just whack it in and keep going, essentially. Just, yeah. So, and then your second question, what was the second question again?
Just at least for the standard library.
Oh, yes, the modules. So in game dev land, especially in Unreal Engine, we don't use the standard library, really. I would love modules. I would really love modules, but we would need to do so much work to the build tool. Yeah, I think that's a job for, we'll see what Epic does. And if Epic gets it working, then we'll see if we can bring it back to us ourselves. But that's not something I think we could ever really do feasibly. Thank you.
Hello, thank you for the talk. And it was a very interesting story. Did you try to convince product or management for such things, or you just
It was an easy sell. So our engine lead, he's very much wanting to keep, because Sea of Thieves is a live game. We don't want it to be decaying into dust, really. So no, our engine lead, he saw the value. It was just, it is the prioritization thing again. So like, it's an easy sell. So like, as long as you can make the time to do it, people didn't have an issue with me doing it. In fact, they championed me to do it. So yeah, it was definitely something we wanted. It's just finding the time.
Thank you.
Thank you.
I was wondering how much the platforms decide the compiler version for you. I do a lot of these same things at Bloomberg.
Yes.
But we do compiler versions basically the same way you were just doing the language switch versions.
Yes. So they don't really dictate, as far as I know. At least with UE5, whenever we were working with Everwild, we were trying to stay with Epic and just using their, basically, if it compiled on this version, then we knew it was fine. And some of us would go to later versions, so I was always trying to push to 19.44 because I love dynamic deop. So like, we always had some people on different versions, so that was never really much of a problem for us. It never became a problem. Obviously, though, using more latest and greatest, you're more prone to maybe getting ICEs or something out there. But that's something that you can work around. Yeah.
Yeah, I was just wondering also, as you mentioned, modules, it's not until about 15 that you get functioning modules from GCC.
Oh, okay, yeah. Yeah.
So it's like if you're stuck on GCC 13, you really can't get that.
We're not GCC at all. I just give that as an example.
okay.
No, we're not in
I wasn't
GCC.
sure which compiler it's like the other.
We're an MSVC. We're an MSVC for all of the Xbox platforms. Yeah. So it's mostly MSVC. Yeah.
So regarding, I know you obviously mentioned everyone's excited to use all the new C++20 features
Yep.
that you've upgraded. Now looking at the philosophy of upgrades and technical debt and all that,
Yep.
to what extent would you say your use of new C++20 features is only on new features that you guys are implementing for the game, or have you gone back and said, this thing that we made a while ago could be improved if we use C++20 features?
No, it's very hard to justify refactors, unfortunately.
I imagine.
It's certainly much you see it going forward in new stuff. I haven't heard of any of our developers refactoring something to make use of the new features, to be perfectly honest. If it works, don't break it, essentially.
Good enough for me.
Yeah. Thank you. That looks to be it. So thank you all for coming.